The other type of visual representation of two-stage probability is a tree diagram. Um, I think you'll see why it's called that when we draw it. Let's look at again experiment of tossing two coins and draw the tree diagram. So the way we draw a tree diagram is we start from a single point and we draw two lines out like this. And this represents the first toss of a coin. And at the end of each of these lines, we put one of the options. We could either get heads or we could get tails. Okay, and then we toss the coin a second time and we make a second set of branches. And now we have the result of the second toss, can be either heads or tails. Now, this is toss 1. This is toss 2. And now over here we list all the outcomes. Now, the first outcome, we read from this point along this line and then along this line. And then that outcome is heads, heads. Then the next possible outcome, we start again at the point over here, follow the line to heads, but this time we got tails in our second throw. And then we keep repeating this. Tails, heads. Tails, tails. And that is how we draw up a tree diagram. So the total number of outcomes here, part B, is each of these possible outcomes here, or how many branches do we have at the far end of the tree? There are 4. Let's calculate some probabilities. Probability of 2 tails. There's one option that has 2 tails, and there were 4 total outcomes. Probability of 1 tail. There are 2 options that have 1 tail, 4 total options. Probability of at least 1 head. So this now includes all the options that have heads in them. 1 head here, 1 head here, and there is at least 1 head here. So that's actually 3 over 4. Now we can also use tree diagrams to show experiments where there is no replacement. Okay, so in this example, we have a group of 3 people, Annabelle, Brody, and Chris. We need to choose 2 people from this group, but once a person has been chosen, they can't be chosen again. So to put all this in a tree diagram, we start again from one point, and in our first choice, we have 3 possible options. We could choose Annabelle, we could choose Brody, or we could choose Chris. Now, our second choice, however, will always only have 2 options because each person cannot be chosen twice. So after we've chosen Annabelle, then the only options we have are Brody and Chris. After we've chosen Brody, the only options we have are Annabelle and Chris. After we've chosen Chris, the only options we have left are Annabelle and Brody. So now to list all the outcomes, we just start from this point and follow the branches all the way out. And we have AB, AC, BA, BC, CA, CB. Those are the total outcomes. Okay, so calculating some probabilities. The probability of Annabelle and Brody. The two outcomes that contain both Annabelle and Brody are AB and BA. So that means we have two favourable outcomes out of 6. The probability of there being Chris in the group is 1, 2, 3, 4. 4 potential groups have Chris in them. The probability that a choice has Chris or Brody is actually going to be 1, because Brody or Chris are in every single group. Okay guys, you are going to go to the textbook and do some examples on arrays and tree diagrams now. And after you've finished your textbook work, that's going to go across 2 periods, you should be able to do these 3 things listed here. So make sure you come back and check that you can do these things after you've completed the independent work. Thanks guys.